Uh, we are going to check onto Engineering Mathematics, Year 2, Ordinary Differential Equations. Ordinary differential equations are equations that contain at least one differential coefficient. There are some examples here. There are 3 examples of ordinary differential equations. The first example is first order. First order differential equation. Then this is because it has got its first derivative, and then we have the second order, which is second derivative. Second order differential equation. And then this one here is the third type that has a first order but fourth degree. So this one is first order fourth degree differential equation. Let us just have the first example of first order differential equation. First order differential equation. First order differential equation takes the form dy dx is equal to function of x function of y. And then here, just by collecting the like terms, so that all functions that have x be on one side of the equal sign, and the ones that have function of y be on the other side of the equal sign, just to balance the equation, we'll come up with dy g of y, function y, is equals to function of x with respect to x, f of x dx. And this become the solution of this. So if you have an equation, by solving this to this form and simplifying further, you will have gotten your answer. Let us just look at one example of first order differential equation. Let's look at one example. Dy dx is equals to sine squared of y sec squared of x. This is a first order differential equation. You can see dy dx. If it were d squared y dx squared, it would have been a second order differential equation. So by solving this, we first collect the like terms, just like we said before, so that we come up with dy all over sine squared of y is equals to sec squared of x dx. We have simply multiplied both sides by dx and divided both sides by sine squared of y to give us this simplification here. So to simplify this further, we are going to integrate. This implies integration of 1 over sine squared of y with respect to y is equals to integration of sec squared of x dx. Now, up to here, I hope we are together. 1 over sine squared of y is equal to cosec squared of y. So we just come here and say this implies that cosec squared of y with respect to y is equal to integration of sec squared of x dx becomes tan x. And then moving further, we can also note that we can simplify this one further. If you integrate cosec squared of y with respect to y, you will come up with negative cot y. So, minus cot y is equals to tan x plus a constant of integration. This becomes our solution, but we can simplify it further by collecting or remaining with one constant on one side. We can bring that one constant here and take cot y that side, so that k, it is positive k, but if it crosses the equal sign, it's still positive k because it's a constant. We don't know what constant it is. So we have k is equal to, this one is a negative, crossing equal sign becomes a positive, equals to tan x plus cot y. This one becomes our solution. So it is just as simple as such. Ordinary differential equations, first order is always the simplest to simplify, or rather to solve. But we'll move to the second order. We'll also check how to simplify it, and also first order, fourth degree. We do online tutorials. If you have any questions, you can approach us and we'll simplify them further for you. Our aim is just to make you understand that maths is the simplest subject ever. So let me just hope up to there you understood everything, and till we meet again, for now, goodbye and thank you for watching.